The violent shaking caused by earthquakes can severely damage structures. In 1971, a large dam was seriously damaged in a quake in California's lower San Fernando Valley. The earthquake made the crest of the earthen dam slide loose, leaving the top of the dam just 2 meters or about 6 feet above the water it held back. After draining much of the water from behind the dam, local leaders quickly made plans to build a new structure. Whenever an earthquake strikes, the natural question to ask is when another might hit. To answer questions like this, scientists conduct hazard assessments. A key part of hazard assessments for earthquakes is the reoccurrence interval, sometimes known as the return period. The recurrence interval is the average time that occurs between two events on a fault or in a source zone. If you look at this photo here, you can see the hazard maps of where more earthquakes are likely to happen in the future. So the darker color reds show areas that earthquakes are more likely to happen. To figure the recurrence interval, scientists divide the number of years that records have been kept by the number of events that have occurred during that time. For example, if the scientists have 200 years of data and there have been 5 earthquakes in the area during those 200 years, then the reoccurrence interval is 40 years. Does that mean that an earthquake will occur every 40 years in that area? It is not quite that simple. The rate of the earthquake recurrence can vary. The longer the history scientists are able to gather, the more accurate the recurrence interval. Because scientists have had reliable instruments to record seismological data for only a short period of time, we do not have a complete earthquake record. We know about some older earthquakes from evidence they left in geologic record, but we cannot pinpoint when they occurred. Scientists know that earthquakes are likely to occur in the same locations. The conditions that caused the original strain build up again and need to be released. To increase their understanding, scientists often dig trenches in these areas. Then, they study the rock for evidence of past earthquakes. They might see evidence of the ground shifting or thrusting in the rock record. They then date the rocks to determine when the earthquake occurred. More data from a longer period helps increase the accuracy of the earthquake recurrence interval. But the precision of the interval from the method is much less than from observing earthquakes directly. You can see here a photo of the rock layers that seismologists and scientists look at. Scientists use information about past earthquakes to create seismic hazard maps, which they continually update. These maps show areas where seismic activity is likely to occur, and they are color-coded to indicate the areas of highest probability. Seismic hazard maps have many uses, from building bridges to emergency preparation to setting insurance rates. While recurrence intervals and seismic hazard maps are important tools, they cannot forecast earthquakes. Recurrence intervals only describe the past occurrence of random events. A forecast looks at the likelihood that the event will happen in the future. It does not predict when or if earthquakes will happen again. However, the recurrence intervals are an important planning tool. After scientists and engineers studied recurrence intervals and other data, a new Los Angeles dam and reservoir were built in 1976, about 1 kilometer or about 0.62 miles from the old dam. In 1994, their work was tested when an earthquake equal to the San Fernando event struck. Thanks to the information gathered from the recurrence intervals and the planning of the engineers, the dam experienced only minor cracking.